Hi, so in this video we're going to be factoring special cases. The first special case is called a difference of square. It's a difference of square where I have a squared plus b minus b squared because it's a difference. I can factor it out as a minus b times a plus b. Okay, so now on this one I can identify a difference of square first of all because I have a subtraction, and second one because both terms of that binomial have a perfect square root. So in this case, k squared, the square root is k, and the square root of 9 is 3. So that means that I can factor that this as k minus 3 times k plus 3. My next one. Again, as you can see, all of those factors, this one, 25, has a perfect square root. V squared has a perfect square root. As long as the exponent is even, that means that has a perfect square root. And 16 have a perfect square root. So this one I can factor it out as 5v minus 4 times 5v plus 4. Okay, so my next one is called a perfect trinomial, right? And there's a couple of things that we need to check to find out that if it's a perfect trinomial. First of all, the coefficient of the quadratic term and the constant term, so coefficient of x squared and constant term have a perfect square root, right? And now, right, so my square root of those two are 4 and 3, right? So the square root is 4 and 3. Now, the linear term is going to be double the multiplication of those two. So if I multiply 4 times 3, that's 12, and 12 times 2 is 24, right? So this one, right, is a perfect trinomial, and I'm going to factor as 4m plus 3 squared. And that's it. Next one. So n squared plus 8 plus 6, when the a is 1, it's easy to identify a perfect trinomial because it's the square root. This one has a perfect square root, a constant term, and this term is double that square root, right? So as you can see, right, this is, I can factor out two numbers, I multiply and give you 16, and you add them and give you 8, or n plus 4, right? And I can simplify that as n plus 4 squared. Again, this one has a perfect square root, and this term is double that square root. Now, this one is a binomial, so I'm going to first check if I have a common factor. There's no common factor. My next step is to check if it's a difference of square. So 9 has a perfect square root, m squared has a perfect square root, and 4 has a perfect square root. So that means that I can factor this as 3m minus 2 times 3m plus 2. This one. My first step, again, with every single binomial, every single polynomial, my first step is to check if I have a common factor. In this case, I have a common factor of 5 and x squared. So my common factor is going to be negative 5x squared. So that means that this is, when I take out a common factor, I'm going to divide by that common factor everything, and that's what I'm going to have inside of the parentheses. So that means that I have x plus 3, and that's factor out. Again, first step, I'm going to find if there's a common factor. In this case, my common factor is 3x squared. So I'm going to have x squared plus 12x plus 35, right? Now I'm going to check if I can factor out that trinomial, right? So two numbers that you multiply and give you 35, and you add and give you 12 are 7 and 5. And I'm going to start by factoring out my common factor, so negative 4n. So I'm going to have n minus 8. And that's it. There's nothing else that we can simplify or factor out on this case. Again, I'm going to start by factoring out my common factor is 2. So n squared plus 17n plus 42. And now I can factor that. So I have n plus 6, n plus 7. 6 times 7 is 42. 6 plus 7 is 13. The last one again. Start by factoring out. So negative 2 n squared minus 4n minus 60. Negative 2 and minus 10 and plus 6. Again, it's minus 10 because multiply them. It's going to give you negative 60. And subtract it, it has to give you negative 4. So negative 10 has to be the negative 1. And that's it for this lesson. May the force be with you.